Hello everyone, I am Shashank. Today we are going to see what is BMP. It is a file format as well as an image extension for storing images. So today we are going to see it in terms of image extension. It is a bitmap file format. First we are going to look into how far it is helpful for us in day-to-day life and how far it is going to fulfill our needs. So compressing BMP is a good idea if you want to share those files with others or if you want to save them on your computer. This BMP bitmap file or uncompressed pixel based images. While the file format enjoys universal support among Mac and Microsoft Windows applications, the large file size makes less size, which is ideal for general use on both the web and local computers. Convert a bit image to a smaller file format or archive it in a zipped file folder and you can mail it further. So first we are going to see why, what and how it is useful for our life. The BMP file format, also known as bitmap image file or device independent bitmap (DIB), is a file format or a simple bitmap. Is a raster graphic image file format used to store bitmap digital images independently of the device, such as graphic adapter, especially on Microsoft Windows and OS/2 operating systems. The BMP file format is capable of storing 2D digital image of arbitrary width, height and resolution, both monochrome and color, in various colors, depths and optional with data compressions, alpha channels and color profiles. So these are the different structures: bitmap file headers, DIB headers, extra bit masks and so on, and it is displayed in tabular form with structure name, optional, size, purpose and comments. So we'll look at in according to the structure name. First we'll look into the bitmap file header, which is it has no options, it is compulsory for header file in the BMP extension, which with a size of 14 bytes. It is for the purpose to store general information about the bitmap image file. DIB header, it is also no optional and it is also added to the BMP extension. Fixed size, however 7 different versions which is exist with this DIB header. The purpose to store detailed information about the bitmap images and define the file format. Extra bit mask, yes, there is an optional like 3 to 4 D words which is optional to add to the header main image file. It is for the purpose to define the pixel format. Structure name, color table, it is semi optional while different colors which includes in the image, and it depends upon the type of compression you need and the reduction of the colors, etc. So it is semi optional. Size is variable size to define the color used by the bitmap image data pixel array, and which is mandatory should be less than or equal to 8. Gap 1, it is also an optional variable size. Structure elegant pixel array, which is no optional, where is the it is stored in variable size to define the actual values of the pixels. The pixel format is defined by the DIB header or extra bit mask. Each row in the pixel array is padded to the multiple of 4 byte in size. So these are the different structure names. So you can go through the each size, the optional size, the storage size and the purpose and comments which is given for each headers. The same follows here. So now we are going to look into the color table, how it is going to store the colors, how you're going to detect the colors and compress the image further. The colors in the color table are usually specified in 4 byte per entry, which is 8, 8, 8, 0 and 8, where 0 is non-entry and the remaining variables from 1 to 8 which is indicated as the entry has according to the 4 byte format in RGBX notation. The color table used with OS/2 bitmap core header uses the 3 byte per entry, which is 8.88.00, which are non-entry zeros format for DIBs loaded in memory. The color table can optionally consist of 2 byte entries. These entries constitute indexes to the currently realized pattern instead of explicit RGB color definitions. Microsoft does not disallow the presence of a valid alpha channel bit mask in bitmap v4 header and bitmap v5 header for 1 bpp, 4 bpp and 8 bpp index color images. So Microsoft doesn't allow the v4 header and v5 header for such 1, 4 and 8 bpp index color images. So which indicates that the color table entries can also specify an alpha component using 888 and 0 to 8 and 0 to 8, which are the optional and which has an excess entries. You can see the format via RGB QApp and .rgb reserved members, where 0 to 8 is in reserved members, the optional which is exists between 0 to 8, the number which is allotted in that slot. However, some versions of Microsoft documentations disallow this feature by stating that the RGB quad.rgb reserved member must be 0. So earlier we have seen that the 8.8.8 to some other 2 bytes which is from 0 to 8 and 0 to 8, which is an option, but here the Microsoft documentation disallow this feature by stating that the RGB quad.rgb reserved member must be 0, where you have seen the format which is earlier, the format for use of OS to bitmap core header, which is of 3 byte, 888 and the remaining 2 are zeros. It follows the same format. Continuing further, so now we'll look into the pixel storage, how we are going to store this image into pixels and compressing them and forwarding the further. The bits representing the bitmap pixels are packed in rows. The size of each row is rounded up to a multiple of 4 bytes, a 32-bit D word by padding. For images with height greater than 1, multiple padded rows are stored consecutively, forming a pixel array. The total number of bytes necessary to store one row of pixels can be calculated as above. The row size, which is calculated in bits per pixel into image width plus 31 by 32 into 4, which gives the image width and is expressed in pixels. So according to this formula, we can calculate the row size, the total number of bytes necessary to store on one row of pixel. The total amount of bytes necessary to store an array of pixels in an n bits per pixel BPP image with 2 power n colors can be calculated by accounting for the effect of rounding up the size of each row to a multiple of a 4 byte as follows. So the image to store an array of pixels in an n bits per pixel BPP image with 2 power n colors and rounding up with the size of each row to multiply it by 4 byte, which is done by pixel array size equal to row size into image height. So the row size is calculated earlier, which is bits per pixel into image width plus 31 by 32 into 4, which is multiplied with the image height, then you will get the pixel array size for each pixel. So the total bitmap image file size can be approximated as above. So we can approximately give the size of the image file in according to the bitmap image file size. A file size which is similar to 54 plus 4 into 2 power bpp plus pixel array size, which gives the approximated file size of the image which is going to be generated for further transfer. Only image with 8 or fewer bits per pixels must account for the palette. 16 bpp images or higher may omit the palette part from the size calculation as follows. File size, which is similar to 54 plus pixel array size, so which gives the pixel array size which is calculated earlier, which is row size into the image height, and the row size which is calculated for the earlier, which is bits per pixel into image width plus 31 by 32 into 4, the both formulas which is dependent on each other. Then further it is calculated the file size, which is 54 plus pixel array size. The original value which is added here with 54, the file size, exact file size is decided, and the file size which is finalized, and the compression will be done perfect. So have a rough sketch what we have seen today, so which is BMP we have turned to, and what, why, how, which is done, and we are using it. So the different structure names, the header files, how far they are useful, the purpose of it, the commands, and the color table, how we are going to store the image colors and compress it further, and the different bytes for entry, and in according to the Microsoft Windows applications, how they use the bytes and which bytes are considered, which are optional, etc. we have gone through. And the pixel storage, the storage of pixels, how they are going to do, how they are going to declare the pixel storage, which is in. Yeah, thank you.